on the problems we are looking at, as you can see here, selected problems from the 2019 round 2 junior paper. Just hold on, please. Let me just put the light on. Last week we did the 2020 junior paper. We did all the problems, all 25. This time we are going to just select some problems from this paper. The early ones, which are generally quite easy, I'm going to ignore. Okay, so you can see we go straight into problem 5. And of course, I don't want to repeat this, but I'm going to assume that all of you have seen the problems, as I have asked you several times to do. There's no point in coming here without having seen the problems and only listening to the answers. Okay, you don't do mathematics that way. So you've been given a chance to see the problems, quite a few chances, quite a few days. So I'm not going to spend time describing what the problem is all about. Okay, the first one, you got square root of something and a plus 20 plus square root and another square root. So you start with this, the one which is right inside, and this is, there is square root of 20 plus 16 is square root of 36. So that's 6. Now you have 19 plus 6, which is 25. And you're working out the square root of 25. And that is 5. And now you're adding 20 plus 5 and finding the square root of that. And the square root of 20 plus 5 again is square root of 25, and the answer is 5. Okay, so that's straightforward, I should think. The next problem is problem 6 of 2019. And here you have a problem where you are asked to find the percentage of the diagram which is shaded. Okay. So we need to know what percentage of the diagram is shaded. You've got quite a lot of pieces which are shaded here, and it's not quite clear as to how much of the square, the original square, is shaded. It's not clear at all. So we have to figure out some way of making it easy enough to estimate it. I noticed that the smallest piece is a quarter here. So why not try to break everything into quarters? Right? And to do that, you have to draw lots of horizontal lines. So you draw 4 horizontal lines and 4 vertical lines. And now you've broken up the entire square into 16 smaller units, because I'm breaking it up with 4 by 4. So now you got 16 smaller units. And now interestingly, in this smaller units, you can see if I go into each one of these, if I go into that, half of it is shaded. The next one, half of that is shaded. and again, half of that is shaded, and so on. Each one, only half is shaded, you see, no matter which one you look at. So the entire part which is shaded is just half of everything. So the shaded part occupies a half. But the question is, what percentage of the diagram is shaded? We can say half of the diagram, but a half as a percentage, it represents 50%. So it's very important to answer the question. See, you might have said half or a quarter or whatever, but you must answer the question. Always read the question and go back and answer it. A lot of people get things wrong because they don't read the question. They come to almost the solution, but just because they didn't read the question, they get it wrong. So let's look at the next problem. So the next problem we go to is problem number 8. Here the problem asks, how many paths are there from the point A to the point B? Now if you, and they say you can only move downwards and to the right. So you have to move along these roads. So for instance, I can go like that and down like this, to the right and downwards. In other words, I can take the shortest possible route. I don't go backwards. Okay, so you can take that kind of a path, or you can take any other path. There are quite a few of them. So the question is, how many altogether, how many such paths are there? This problem can be quite complicated if you had a more complex figure. But even here, you would be able to count it. But there is a good chance that you might miss out one or two unless you got some systematic way of counting it. Now I'm going to show you something which is very interesting, which will help us to solve not only this problem, but much more complex problems. And what we do is the following. We have several squares here, or rectangles. Okay, now suppose I somehow got to this. I want to get to this point here, from here, right? That's your start. So this could be represent any one of these rectangles. And suppose I somehow figured out how many paths there are from A to this point. Right? Suppose we know the number of paths from A, that A there we're talking about, to this point. I'm going to try to write clearly because a lot of complaints. I'm going to read this. Number of paths from A. This horrible looking thing here is from A to this point. And likewise, the number of paths from A to this other point here, right? I'm going to write down the number of paths. Okay, suppose we don't know. Suppose you've had 3 paths which you calculated was from A to this point, and suppose you calculated 4 paths. Right? Just to choose some figures. Now the question is, how many ways can you reach this point here? Now you will agree that the only way you can reach this point is to either from there or from there. There are no other ways in which you can reach this point. And if there are 3 ways in which you can reach this point, right, and there are 4 ways in which you can reach this point, then you've got 3 paths here and another 4 paths here. So altogether, the number of ways of reaching this point here is 3 plus 4, which is 7. right? So in short, if you know these two numbers, you can calculate this one, see, in any of these rectangles, because you can only move downwards or to the right. So bearing that in mind, we can apply that principle to this problem, okay? And I'm going to see whether I can place numbers at each, we'll call this node, or at each intersection point. And these numbers will have to be the number of paths from A to this point. Look, if I take this point here, how many paths are there from A to this point? You will agree there is only one. Okay, okay, there's only one way in which you can reach this point here. Likewise, there's only one way in which you can reach this point from A. And here it's the same story. And here it's also the same story. And here it's all the same story, right? Now here you can actually find, you can actually see how many parts there are from A to this point, because one of them is this and the other one is this. So there are two. But in actual fact, I'm going to add 1 plus 1, which is still 2. See? Because this is what we said here. That plus that gives you this. So likewise, this plus this will give you that. That plus that will give you that. That plus that will give you that. 3 plus 3 is 6. 6 plus 4 is 10. So if you apply this principle several times, you can come very quickly to this answer without having to count all these paths, you see. So there are 10 paths from A to B. See, this is what problem solving is all about. You try to simplify the problem and figure out exactly how you go around in the simplified situation, and then try to see whether you can use that information to solve the bigger problem. So the answer to this problem is 10. And we learned something very interesting here, because you can, if I had, for instance, if I had another 3 down here, suppose I had this kind of a grid. So again, from here to here, there's only one way, right? And now if I want to get to this point here, I'm changing the question. The answer is 10, but I'm saying if you had a slightly more complicated problem, you can do the same thing, and you can say 3 plus 1 is 4, 6 plus 4 is 10, 10 plus 10 is 20. And I can assure you that if you try to do it by counting the number of paths from A to this point here, it's very unlikely you're going to get to 20, yeah? Because you'll get very confused. You wouldn't know which one you counted and which one you didn't count. So you can see, if you use the sort of what I call the primitive method, then it's going to be a very difficult way. But see how quickly I got to 20 by using this nice principle. So you can use this to solve any one of these problems of that type. I want you to go to my book. All of you will be getting, as long as you have registered, you will get the book free of charge. My book is called 1000 something. And there you put Control F. Control F means find, right? And type, I'm not sure what you will type, but just type paths, maybe. And you will go straight to that word in the book. And if you type a couple of times, you will see some problems where you got a whole lot of problems involving paths. See? Oh, why should I? I can do it now. Okay, unfortunately, I might take longer than usual. To finish today's lesson. Sophia, I'll answer your question later on. And if we all right, suppose now I want to, right, so there's a book, right? So this is a book called 1000 Mathematics Olympiad Problems, okay? And you can see I wrote this book, complete with the lessons. Now, if you go into, I'm going to put Control F, right? Oh, let me just share the screen with you. Sorry, let's go back. Okay, hopefully now you can all see this screen. Okay, I'm going to type Control F in this on the screen, and you will see a little box comes up there which says find. Now in that find, I'm going to type path, P-A-T-H. Right? There could be many on them, and it says now it's working on it. This thing is somewhat slow, and it will give me all the places where you see the word path. Right? It's taking a long time. Okay. All right, maybe I've got too many things open here, and that is why this thing is taking so long. But okay, but I'm going to, somewhere along the line, you'll come up with something like this. You see, there's a whole section of these tables like this, and you got lots of words here, and hopefully one of these will be something about paths. All right, and okay, you need not. It's taking too long. Godfrey. Okay, if I take something like, for instance, now, if there was a problem on, let's say, exterior angle of a triangle, right? Now, all the problems with involving exterior angle of a triangle, they are numbered here. 433 is a problem which uses that, 447, and so on. And this 8.1.2 is the lesson which deals with exterior angles. So you can go to that lesson and know everything about it. And these numbers here will tell you how to get to a problem like this. So if I take 447, for instance, right, I'm going to search for something else now. But if you go to problem 447, you must type P447, right? So that thing will take you straight into problem 447. Unfortunately, once again, it's taking an enormous amount of time to get there. But it will take you to problem 447, and there you will see a question, a geometry problem, and one of the things that you will need to solve that problem is the exterior angle theorem, that the exterior angle is equal to the interior, sum of the interior opposite angles. So unfortunately, this is taking enormous amount of time to get there. I'm going to now just close up this thing, just to give you, I'm just trying to give you an idea as to what to do here. So let's just close the screen and get back to this.
Prof, there's a hand somewhere, Safi Taleb.
Yeah. Okay, Safi, what is your question?
So where can we find this book?
David, can you just answer that question?
Yes, all learners who are registered for Sangama problem, I have emailed the link with the book.
All right, thank
It's an
you.
ebook. It's an ebook, so you'll get it free of charge.
Yes. If you don't have a book, just send me an email. It's fine. I will check if you are registered first.
Right.
All right.
So you must register online registration, and by the way, you must link. You must click that only once, because if you click it more than once, you lose the book. You're not allowed to share it with anybody. All right. Because the book sells for 520 rand, so you're getting it free of charge.
Wow. Okay.
Okay. Is already the link is there somewhere. David has put it on, but if you still can't find it, you can email him on Google Classroom, and you'll get the answer. All right, I'm going to get on to the next problem now. We took enough time on that. The next problem says a regular decagon is shown. I'm sorry I had to rush through that because we don't have time to discuss that as far as the book is concerned. A regular decagon, so we want to know, what do you mean by a regular decagon? Right? In the first place, decagon, regular means, regular is referring to polygons. In other words, a quadrilateral or a triangle or whatever, a pentagon, right? So this is the polygon which is speaking about. A decagon is one with 10 sides. All right, so regular means that all the sides and all the angles are equal. That is what you mean by a regular polygon. See, so a regular quadrilateral is where all the sides and all the angles are equal, and that's a square. A regular triangle, all the sides are equal, all the angles are equal, that's an equilateral triangle, right? So in this case here, you got a regular decagon, and something is, two lines are joined here, and you are asked to find what the value of x is. All right, so the way to do this now is, I want to just tell you a few things. Again, when you get the book, you can put control find and put polygon or regular polygon, and you will go straight to regular polygon, and you get all the information on regular polygons, notes and all, right? So you can read through that and acquaint yourself with everything concerning regular polygons, and you can try this problem out. Okay, so every regular figure has got a center. See, like this one here. By center, I mean that if I put my compass point here, right, and take the radius to be the distance to a vertex, the circle that you draw will contain all the vertices. See, every regular polygon has got a center. So it means now that this center here is the same distance from all the vertices. I'm going to join the center to all the vertices. In fact, when I join it like this, it actually goes through the opposite vertex. Okay, now I need to calculate these x's. I mean the x. Now when you do that, the x is divided up into 3 parts. And the interesting thing is that all these 3 parts are equal. This, if I call this y, all these are equal to y. And I'll tell you why. The reason for that is these are all radii of a circle, so radii are always equal. And because this is regular, we said that all the sides are also equal. So now you can see you've got 10 triangles, and these 10 triangles all are congruent. The 3 sides reason for that is, you see, two sides and a third side. So all these triangles have got the same sides, so therefore they are congruent, which means that all these angles here opposite the double stroke are all equal because the triangles are congruent. But there are 10 of these y's, right? And they all add up, as you can see, they all add up to 360 degrees, which means that each one of them is 36 degrees, right? And if you look at the x is actually 3 of these y's. See, x is 3 of these y's, and 3 times 36 is 108. So the answer is x is 108 degrees. Right? This is a very, very neat trick with regular polygons. Right? Join everything to the center, you'll get congruent triangles, and you can work out a lot of things once you do that. See, you can calculate all these equal angles also. We say all the angles are equal, you can calculate it. I'm not going to do it, but you can try it. Take a decagon and try to see what are these internal angles. What are these angles equal to? Right? It's not very difficult to do it now that I've shown you this thing. Okay, so the answer to this problem is 108 degrees because it's 3 of those y's. Okay. So let's get on to the next problem. Okay, so we do have a problem 11. Problem 11 says that the consecutive odd numbers are all written down like this. What is the value of n if the sum of the numbers in row n is 1,000? So you got the consecutive odd numbers. You put 1 here, and the next one, you put 2 of them. But you follow it in sequence. You see 1, 3, 5, and then the next one you put 3, the next 3, 7, 9, 11. Then the next 4, and then the next 5. All right, so you got a way of constructing this thing. And the question is, what is the value of n if the sum of the numbers in row n is 1,000? So row n, we cannot see it here. We don't even know what n is, but we are adding the sum of all those numbers which are in row n. We don't know what the numbers are, but what we do know is that when you add them up, you get 1,000. So the question is, what is the value of n? Always see what the question is. So the question is n, and you know that when you add these, you get 1,000. But how does one go around solving a problem like this? Naturally, you say, well, what happens when you add all the numbers in each row? Let's see if anything happens. So if I add all the numbers in the first row, I will get 1. In the second row, it's 3 plus 5. The third row, it's 7 plus 9, which is 16, plus 11, which is 27. The fourth row, right, it's 28 plus 45, 64. And the fifth row is 125. And you ask yourself, is there a pattern amongst these numbers? And with a little bit of thought, you'll see, hey, of course, this is 2 cubed. Right? You should know all your cubes. 3 cubed, 4 cubed, right? If you didn't know it, 4 cubed is 64. And I'm sure you know what 5 cubed is, 65. Right. And you can see 1,000 is also a cube. That's an easy one. That's 10 cubed. See? So the sum of all the numbers in row 5 is 5 cubed. The sum of all the numbers in row 4 is 4 cubed. Therefore, the sum of all the numbers in row n is n cubed. So that tells me that n is equal to 10. Okay, so there's a natural way of solving this problem, looking for a pattern. And once you find the pattern, which is easy enough, you can solve the problem. All right, it's nice to know the cubes, because when you do indices or exponentials, you have to know some basic cubes, like 343 is 7 cubed. See, that's a popular one. And beyond that, you don't get many, right? Like for instance, 13 cubed is 2,187. You're not expected to know that. But you're expected to know at least the smallest cubes. All right, so that takes care of problem 11. We will now go on to problem. Okay, I'm going to just pause here and ask you, give you a chance to respond. How many of you got the value n equals 10? A show of hands. All right, Joshua, Johara, number of you. Okay, I can see quite a few, 18, 19. We got 65 people today participating, which is quite a nice number. Yesterday we had 100, but I can see quite a few of the learners have tackled these problems, but at least we got at least 26 of them got n equals 10. I would presume the others didn't know how to do it, and now you know how to do it, so you are a little richer in knowledge. I'm not going to make the presumption that you didn't try it, because I'm sure you did. Okay, otherwise you know that you will be wasting your time here. So let's go back to our problems and see and get to the next one, which is problem number 12. Okay, problem number 12. Let's read this thing. 18 identical rectangles are arranged as shown below. So you can see a whole lot of rectangles, but they are all identical. That's important. They all have got the same dimensions, in other words. Okay, and there are 18 of them. So they got the same dimensions. They say determine the area. So you need to find the area of the whole rectangle, this whole thing. What is the area? But it's given that the length of the bold path, this part here, this is the bold path. You're given that the length is 36. So how do you go around solving a problem like this? So you got one piece of information that the length of the bold path is 36. And you know that all these rectangles are identical. So all exactly the same. But we don't know the dimensions of the rectangle. Okay. So let the shorter side. Now you see, now we're going to bring in an x here. I'm going to try to find out an equation involving x, because I do know that the length of the bold path from A to D is 36. So if I can work out this length in terms of x, then I have an equation. I can say that length equals 36, and I got an equation involving x, and I can solve it. So that is a strategy. So I'm going to call this x. I don't know that as well. Okay. So we can call that y. Okay. And then what I'm going to do is I'm going to start from here, from one end of this, and I'm going to put down an x here. This length is x. I'm going to find this entire length in terms of x. Now this part here now is the same as that part, which is the side of the rectangle. So that's also x. We said that's x. Now here you got 2 of these. So this third piece is 2x. Now watch. Here you got 4 of them. 1, 2, 3, 4. But lo and behold, this is the length of the rectangle. You see? and it's going to be equal to x plus x plus x plus x. So I don't have to put y here. I can put 4x. Right. We've just calculated that the length is 4x. Now here, this is a little bit tricky because how do you know? It looks as if it's half of this thing. It looks as if it's going to be 2x, but we're not sure of that. You never ever guess. But watch. We know that from here to here, watch carefully. From here to here, it's 4x. And this from here to here is 2x. Therefore, quite right to say that this is 2x. So like that, now you can go to all these and finish it off. I know the writing is a little bit small, okay, but hopefully you can see it. And now all we have to do is to add up all these sides. There's all the dark edges, right? You got x plus 2x plus 4x plus 2x plus x plus x plus x. If you do all that, you'll see that you get 18x. That is going to be the length of the bold path. The length of the bold path, P-A-T-H, is 18x. But we know also that the length of the bold path is 36. So there you have it. You have an equation. In mathematics, you're always looking for equations so you can solve for the unknowns. 18 goes nicely into 36. So x is equal to 2. Right. Now, some people might just say x equals 2 and put down 2 there, right? And they will lose all the marks. The reason being that they're not answering the question. The question is, what is the area of the rectangle? The question was not to find x. So now how do you find the area of the rectangle? Now remember this, to find the area of the rectangle, right, you have to work out AB multiplied by AD, length times breadth, right? Now what is AB? Well, let's see, what is AB? This part here is 4x. We saw the length is 4x. This part here is also 4x. And there's a little x which is sticking down here. So the length is actually 9x. And AD, well, this is 4x. And this is also 4x. But this time you have 8x. So AB times AD is 9x times 8x. So the area is 9 times 8 is 72. X times x is x squared. But we know what x is. X is 2. 2 squared is 4. So it's 72 times 4. 72 times 4. And that is 288. So that's the answer. The area of the rectangle is 288. Okay, so recap again, you know that some piece of information is given. The length of this dark line is 36, and you try to find that length, get one unknown, get an equation involving the unknown, solve for that unknown, see what the question is, and answer the question. And eventually you see you need to work out 72x squared, and you know what the unknown is, substitute, and there you have it. You have the answer to your problem. Okay, so let's just get on to the next problem. Okay, let me just see, how many of you actually got 288? By show of hands? Okay, so there's a fair number of people who calculated this thing, which is not bad, out of my class size of 40 something. At least 20 people got it out. Okay, well done, guys. Okay, now we got on to the problem number 13. You got a rather strange shape here, and you're given some sides in this shape. 11, 9, and so on. And the question is, determine the perimeter of the shape. So, perimeter means if you add up all the boundary sides. So 11 is already there, I know that. This is 9, but this one I don't know. It's an unknown. So let's give a name to it. Now this thing here is also an unknown. Okay, done. This is 2, that's fine. Oh, you've got too many unknowns here. Let's see. And another one. Oh my God. So you got D, you got E. Large number of unknowns. Okay. Now, that's not very nice. But what we can see is that this whole thing is 9. And I'm just checking to see whether some piece of information is missing. Maybe not. Anyway, just one moment, please. All right, now let's have a look at this. We can see that B plus C plus E is, the vertical sides are going to be equal to 9 here. And also, you got A, okay, A, and if you take away 2, you have the distance from A to this point, plus D is 11. Okay. So what I'm going to do is, okay, you can do it this way, and but you're going to have a lot of equations, and it's going to be rather complicated to solve. Okay, so there's a nice way of doing this thing, where we say you don't have to have all 5 unknowns. You can use this 9 and 11 and the 2 to actually reduce the number of unknowns. You see? So, like for instance, if I extend this line here a little bit, watch. Oh, sorry. If I join this and also join this, then you can see that this part here is 2. See, this part is 2, and this part is D. See? So, and likewise, if I join these, just complete all the rectangles here like this. See, then we can see that this is, the whole thing is 11 plus D. So we can calculate A, because that's okay. Let me finish all these. So this part is from here to here is C. I'm sorry, you can see I'm kind of struggling here. You got C, and from here this way, this is also B, right? This part here is D. D is the whole thing. So this is D minus 2. Because the whole thing here is D. Right? This is D minus 2. So what we do have is that when you add up, what we need to calculate is just these boundaries. So you need to calculate your perimeter. Is equal to, we know it's 9 plus A plus B plus C plus D plus E, right? Coming all the way, and there's a 2 here also. I forgot to mention the 2 along the way, plus 11. Starting from here and going all the way, you get to this. So this looks very complicated. We don't know any of these. But now watch. We do know that, for instance, A plus D minus 2, A is the whole thing. A is the whole thing. So we do know that A minus 2, that's that one there, plus D is 11. See? A plus D minus 2 is 11. So A plus D is 13. So we do know that. In other words, I can replace these two here by 13. So I got 9 plus A plus D is 13, right? Plus 2, which is 15, plus 11. So I got 26 plus, then I got this other thing, B plus C plus E. See? Because A plus D is, now B plus C plus E, this is, so the perimeter is 26 plus B plus C plus E. But watch, B plus C plus E is nothing else but 9, you see? So you have 26 plus 9, which is the wrong answer actually. Oh, yeah, there's another 9. So you got 9 plus 11. Anyway, whatever it is, the answer turns out to be 44, because we know what B plus C plus E is. Okay, somehow I seem to have missed something here. All right, please just check this thing out. I'm sorry it took such a long time over this. What I'm getting here is 26 plus 9, which is 35. I don't think the answer is 35. Sorry, I took such a long time over this. There are different ways of doing this thing, but the nicest way is actually, this diagram here tells you a much easier way of doing this thing rather than finding all these unknowns. And the way to do it is, now watch. This is the creative way of doing it, the kind of way that problem solvers will do. So what we do is we take this part here, right, and we shift it to the boundary. So I'm taking this edge from here and shifting it to the boundary, and I'm shifting this edge here also, this dotted line. This edge and this edge are shifted to the boundary. Then I will have completed this side here. Okay? And likewise, I take this part of this line here, is just a small piece of that line, and take that and push it to the boundary again, bring it down, and then you have this piece left over. So the perimeter is actually equal to the entire rectangle. I've taken all the dotted lines and pushed them to the end, plus 4. That's 2 plus 2 is 4, right? The entire rectangle, you know the sides, 9 plus 11, right? And the perimeter of a rectangle is 2 into length plus breadth. 9 plus 11 is 20, and 20 times 2 is 40. So the perimeter of the rectangle is 40, right? So plus 4, because these two were not pushed to the edge. So the answer is 44. See, that's a very much easier way of doing this thing. But it's a creative way. Right? It's a creative way of solving this problem. Okay, I took so long over this. I must apologize for that. Let's get on to see how many of you actually got 44 by show of hands. Okay, it's a tough problem, so I can appreciate it if you have not been able to solve it, but I can see at least 13 of your students actually came to 44, which is very nice. All right, so let me get on to the next problem. We're going to problem number 14. Problem number 14 is not so difficult, right? It's much easier than the last one. What it says here is that for any positive numbers, A and B, positive whole numbers, right? You got an expression A something B that it looks like a multiplication or something like that. So you can say it's just like A plus B or A times B or A minus B, but it's a new one, right? It's a new operation. We normally know of the operations of addition and multiplication and division, but this is a new operation, A operation B, if you want. You can say, maybe you'll call it A star B. A star B, there's a new rule for this. And the rule is you square A squared plus the second number, the square of the first number, plus the second number, and you divide that by 2. So whenever you see this, this is what you would do. You will say, when you simplify it, that's what you will get. So the problem is to determine the value of x. So this x is your unknown. And the question is, find the value of x. But you've got this equation here. Now, it's an equation. You can see it's equal to 70. We know how to work this out because there is a way of doing it. You square the first number and add it to the second number. And then when you do that, you will get x squared plus 19, and you divide that by 2. Square the first number, add it to this, equals 70. And there you have it. You have an equation, a proper equation which you can understand. It hasn't got all these funny symbols in it anymore. You've taken that out. So how do you solve this equation? Well, first let's get rid of the fractions. To do that, I always get rid of fractions when I make equations. I'll multiply by the LCM right throughout. So I'll multiply by 2 here on both sides. That's the LCM. And then the fraction is gone. And now bring all the x's to one side. That's the standard rule, right? And you get 121. You get x squared is equal to 121. Oh, that's a nice number because you know that 11 squared is 21. It could be plus or minus 11, but it's said that the numbers are positive. Okay, so the answer to this problem is 11. Okay, so that wasn't very difficult. You simply have to substitute for that funny looking formula and then have an equation, and that equation will take you straight to the solution. Okay. I'm sure many of you got that out. If you want to show me your hands, show of hands. Okay, a large number of, carry on, go on. I've got 63 participants. I'll be surprised if less than half have got it. If you got it, please raise your hands. I need to have an idea as to how well you are doing. Don't be lazy. The way to raise your hands, in case you don't know, is that on the bottom line of your screen, right, there is something which says, I don't know what it says. I think it says, can anybody help me? It'll say something, raise hands or something.
Reaction.
Reaction, right. Some people might not have that reaction thing. If you press the reaction, you will see that you'll have a hand raise and you can put that on. If you don't have that, you can go to the extreme right of the bottom screen and you'll see 3 dots. And then when you click on those 3 dots, again, you will see one of them is reaction, and you'll click on that, and then that'll allow you to raise your hands. Right, so that gives me quite a few people have raised their hands now, 31 people, which is about 50%. Okay, let's get on to the next problem. Okay, the next problem here says that a diagram shows 2 parallel lines with 6 points indicated. You can see the 6 points, there are 4 there and there are 2 here. How many triangles can be drawn with the vertices chosen from these 6 points? Okay, how many triangles can you draw? Okay, you can have a number of triangles. If I take an example of one particular triangle, for instance, I could take this triangle here. And then, oops, go up to that point. So that's an example of a triangle. Or you could have one like this. See? Or you could have one like that. But as you can see, there are many, many triangles that you can draw. So the question is, how many triangles have you got altogether? If you try to draw the triangles, as it is now, you can see you get very confused. So we have to figure out some nice way of counting the number of triangles. So that's the goal. How do I count the number of triangles? Is there any logical argument that I can use to count the number of triangles? Okay, there is a nice logical argument. What you do is you say, well, a triangle has got 3 points. I have to choose 3 points. Okay, now let me do it like this. Firstly, I will say I will choose both these points and I will call that case 1. Or I will choose left point. By that I mean this one here. And I'll count how many triangles there are. And then finally, I'll take the right point, which is that one, and count how many triangles which have got that as a vertex. See, every triangle has got 3 vertices. So you could have those 2 are vertices, or you could have one of them is a vertex. It could be either this one or that one. So we have to count the number for that one. We have to count the number for that one. But you can't have that none of these is a vertex, because then it means I'm choosing 3 points from here And you know very well you can't draw a triangle with 3 points from there. So there are only 3 situations where you got 2 of these points are chosen, right? And the left point or the right point. Okay, so let's take the first case where both these points are chosen, and then ask myself how many triangles are there if both those points are included. Okay, now both the points are included. So what does this mean? It means now you already got 2 points. You already got 2 points. You have to choose the third point. And the third point can only be from here. So the question is, how many triangles have you got? And the answer is the same as the number of ways I can choose the third point in this triangle. I've got these 2 points. So you can actually see what the triangles are. It's coming down like this. That's one triangle, like this. Right. And another one like that, and another one like that. And you can see there are 4 triangles because you only need to work out the third point. So the third point can be chosen in 4 ways, and therefore the first case leads to 4 answers. So here I've got 4 triangles, case 1. Right, now I choose only this point, the left point. Now I've got only 1 point, 1 vertex only. So to complete the triangle, I need to choose 2 vertices. And those 2 will have to be chosen from these 4. So the question is now, you need to choose 2 dots from 4 dots. Right. Now there are many ways. Now this becomes a chosen vertex. You can choose those 2 and you get a triangle. You can choose those 2. So there are many ways. Now how many ways can you choose 2 dots from 4 dots? Last week we answered precisely this question and the answer was 6. Right? I'm not going to go through that, but the way to choose 2 dots from 4 dots, there's an easy way of doing it. It's 4 times 3 divided by 2. There was a formula which I did last week. Right? If you want to choose 2 objects, letters, dots, numbers, whatever, from n objects, could be people also, or horses, two objects from n objects. How many ways can you do that? The answer is n times n minus 1 over 2. So in general, you got a very quick way of finding out how many ways can you choose 2 from n objects. If you had 100 objects, then 100 times 99 divided by 2. You can answer any one of those types of questions. Yeah, you just have 4 objects, so there are 6 such triangles for the left point. And likewise, if I choose the right point, it's exactly the same problem with another vertex, and there too I will have 6. Those are the only cases. So the total number of triangles you have is 6 plus 6 plus 4, which is 16. So the answer to this question, how many triangles, is, the answer is 16 such triangles. Okay, so let's see who are the guys who are winning with this kind of question, quite a more advanced question, because you're counting and it's not easy to count these. Oh, I'm happy to see that there are fairly good large number of people. I can see at least 18 people have raised their hands, which is excellent. Okay, now I'm sure you'd be, if I, instead of 4 dots, if I had 10 dots, right? Again, you'll be able to answer that question quite easily. Again, you'll do exactly the same thing. You'll say either you have 2 or left or right, but you got 10 dots. So then these numbers will change. I can see this will be 10. This will be 10 times 9 divided by 2. And this is also 10 times 9 divided by 2. So you can answer the question even if you got 10 dots. See? Without having to draw a single triangle, you can actually count the number of triangles. So this is a very important thing in mathematics. How do you count? Okay. All right, so let's get on to the next problem. So we're going to go on to problem number 16 now. And problem number 16 says, a hiker leaves home and walks south for 1.5 hours. So let's draw this diagram. He leaves home and he walks south for 1.5 hours. Okay, this is the southerly direction for 1.5 hours. So let me just put 1.5 here to show that he was walking for 1.5 hours here. And then he moves west is that direction, for 2 hours. So he's going to walk a longer distance now because he's walking for a longer period of time. Okay, and this time he walks for 2 hours. So these don't represent distances, they represent time, hours. Okay, and he takes a break for 20 minutes. So at this point here, he sits down and he has his lunch for 20 minutes. Then they say, assuming, and then he walks directly home along a straight line. So from here, he walks along a straight line. So there are no rivers or forests or any obstacles along the way. Okay, and is walking that distance. They say that he walks at the same speed, always walks at the same speed. So if he's walking here at 20 km per hour, that's too fast. If he's walking at 5 km per hour, here too is walking 5 km per hour, here too is walking 5 km per hour. So it follows that the ratios, this will be 1.5, 2, we can calculate this is 90 degrees here. So we can calculate how long it takes in hours to traverse that distance. Okay, so you have to use Pythagoras to work out this thing here. And how do you do that? Well, Pythagoras' theorem says that the square of the hypotenuse, this is the hypotenuse of a right angle triangle. If we call this x. So x squared, that's the hypotenuse, is equal to 1.5 squared. It's 1,5 squared plus 2 squared, which is 4. 1,5 squared, 1,5 times 1,5 is 2,25. And that gives you 6,25. So x squared is 6,25. If you are not very comfortable with that, you can say x squared is 6.25, because 6,25 is 6.25. And that is, as a fraction, is 25 over 4. So when you square x, you're going to get 25 over 4. So x will have to be 5 over 2. All right, so this means that this hypotenuse is 5 over 2, which is 2.5, and that's hours. So now we've got the total time that he has taken. You can work it out now. It's easy. It took 1.5 hours here, 2 hours here, took a break for 20 minutes, and then he went on for another 2.5 hours. So in hours, you've got 2.5 plus 1.5, which is 4, plus 2, which is 6. So he's traveled for 6 hours and 20 minutes. So that's the total time for how many, oh, the question is how many minutes was he away from home? So you have to translate this into minutes. 6 hours, 1 hour is 60 minutes. So 6 hours is 360 minutes. And you add 20 to that, and the answer is he was away from home for 380 minutes. There are other ways of solving this, but I think this is the easiest way of solving it. You could have said, what distance does he travel? So you work out the length of this. You know the time, right? It's 1.5 hours. So it's the same speed, right? So if you say let the speed be x, then you'll have the same speed right throughout, and you can calculate everything in terms of x. And then you'll have an equation involving x, and you can solve that, and you get the speed, and thereafter you could work out all the other things. That's much more complicated. This way here is a very simple way. You work according to times, because they ask you how many minutes he was away, so you put this in hours rather than distances. All right, so let's get on to the next problem. How many of you got 380 minutes? I'm sure you had all kinds of interesting ways of doing it. Oh, I'm happy to see that many more people. So you got 23 participants who got this right. Well done. It might very well be it's the same people who are getting it all the time, which is not very satisfactory. But why I'm saying not very satisfactory, it'll mean that there's a strong likelihood there's a large number of people who are not trying the problems. Okay, I mean, that's most unfortunate, because if you just sit here, you know, and with folded hands and you look at this screen, nothing is going to happen. In that case, you will just have, you will know the question and you will know the answer, and you have done nothing in between. So I always ask you to try it. Spend some time trying it. Okay, now we are going to go on to the next problem. Problem number 17. Problem number 17 says the following. There are 367 pupils in a school. And the question is, what is the probability that, expressed as a percentage, that at least 2 of them have their birthday on the same day? Now, this looks like a very complicated problem. All right. For the moment now, let's not worry about the question itself. We'll come back to the question later. But we've got the story. We've got 367 pupils. And you want to know whether 2 of those pupils, at least 2, have their birthday on the same day. Now, how do you go around approaching a problem like this? Okay, by saying same day, we have, how many days are there in the year? You've got, if I put the days as dots here, the number of days is 365 or 366, depending on whether it's a leap year or not. So if I put the days down like this, I'll show you why I'm going to do that. And then I put the pupils here. And again, I'll have a number of pupils. And there are 367 of them. So there are 367 dots in the top line and 365 in the bottom line, right? Now each pupil has got a birthday. right? And I'm going to, I didn't number these days because I wanted deliberately, because I wanted to say, okay, let me take the first pupil and say, suppose he has his birthday on that day. Right, you can only have one birthday. I can't put this on another dot. It means that pupil has got two different birthdays. Right, so that's quite impossible. Okay, so he's got only one birthday. Okay, so we'll take that on. Now let's take the next guy. Right, now I'm going to try, take the next fellow, and I'm going to assume now that no two people have the same birthday. I'm going to assume that. So there's an assumption, which I'm going to write down. It needs to be explained. So assume no two pupils have the same birthday. So what it means is that you got 367 pupils here, and you got 365, right? Now you'll see that that's not possible. The reason being that if I take the second one, you can't have the same birthday as the first. But if you take the third one, he has to go on a different day because he can't share the birthday with the other guys. So like that, now each one will take a different slot. But you got 377 here, and maybe if you take the 366, if it's a leap year, you've exhausted the days, because there are 366 altogether. And one of those is isolated. So this guy is going to be a loner here, but he also has a birthday, which means that he should have been, he has to be linked up with one of the others. But this thing has already been filled. All these other people. So now you see the two people have the same birthday. But we assume that no two pupils have the same birthday. So this is impossible. Right. So to summarize, this is very important and it's rather tricky. We have concluded that it's not possible for two people to have, it's not possible for no two people to have the same. It's always true that at least two of them have the same birthday. I'll repeat that. It is always true that at least two of them will have the same birthday. So what does it mean? It means that the probability, it always happens. So what is the probability? If something always happens, then the probability is 100%. If something always happens, the chances of it happening is 100%. There's a 100% chance, guys, that there is none amongst you who is 105 years old in my audience. There is a 100% chance. Because there's no two of you, nobody in this audience will be 105 years old. All right, if there's anyone, you can please raise your hand. Okay, and then I'll change that to 150. Okay, so there we go. The answer is 100%. That's the probability. Okay, so let's get on to the next problem. Problem number 18. That's 19. Okay, problem 18 is the following. Determine the value of k if this is true. All right, now this is a problem which actually tests on whether you know how to work with fractions. So It shouldn't be very difficult at all. So if you work on the left-hand side, okay, just put 1 over k here and work the right-hand side out. I mean the left-hand side. 20 over 19, leave that intact. You're adding 2 fractions, 18 and 20. Now, if you can't find the LCM, just take the product. It might be difficult to find the LCM. So I will just write down the product, 20 times 18. Right, then what happens? 20 goes into this 18 times. You need not find the LCM. You just have to find something which is a common multiple of these two. So 18 goes into this 20 times. So that's what you have. Okay, so what have you got here now? The numerator has got a 20 in it. You're multiplying it by 18 plus 20. It's 38. The bottom has got 19 times 20 times 18. 19 times 20 times 18. The 20s cancel. The 19, you don't have to multiply. Last week I told you that you don't have to multiply. You just use fractions and cancel. 19 goes into 38 2 times. 2 goes into 18 9 times. See how beautiful it is when you use fractions and cancel. And this becomes 1 over 9. No need to multiply all these big numbers. Fractions do the work for you. So 1 over k equals 1 over 9. So k is 9. So that's the answer to that problem. Right? K equals 9. I won't ask how many of you have got this, because I'm sure a fairly large number of you have got this problem, have solved this problem. Okay. I want to go on to problem number 19 now, because it's problem number 18, that one. And problem number 19, now it starts getting a little bit more difficult. Problem number 19 says 2 identical circles are drawn inside a rectangle as shown. Okay. There it is. You got 2 circles inside a rectangle. And then one of the diagonals is joined. There's a diagonal. And then once you do that, a certain part of that is shaded. And you can see the shaded part is a rather queer kind of an object. It's got all kinds of funny looking shapes here, right? And they say the area of the shaded region is x minus y pi. So the question is, they say, what is the value of x plus y? So in other words, I need to calculate the area of the shaded region. And that looks really weird, because how the heck are you going to calculate the area of such an irregular shape? Okay, I'm just going to see whether I can use, I use certain things here, but I might be able to use okay, let me use this one here. All right. Now, let's take these shapes. You see the shape here? I put a tick there, right? At the top, above the diagonal, there is one piece there which is exactly the same as this shape. If you look at it, you'll see that one there has got the same shape as that. Okay. Okay, this is the first, there are 4 shaded parts. This is the first of the shaded parts. Now let's try to take this shaded part here. This shaded part is exactly the same as that one there. Right? Likewise, this shaded part here is exactly the same as the shaded part there. That's the white. There's only one little thing that remains here, and that's that guy there, but that's equal to that little fellow there. Okay. Right, which means that there are two areas which are exactly the same. Okay, now let me just explain that. I don't know what the area of the shaded part is, so I'm going to give a name to it. I'm going to say I'm not going to call it X because I already have X and Y. I'm going to give a name. We've got S for shaded, right? Let S be equal to area of shaded region. This is a region. Right. Now, you'll notice now that if you add the bottom part to the ticks at the top part, 1, 2, 3, 4, those are the ticks, right? You've got everything inside this rectangle except the two circles. So this area of this shaded part plus the area of itself at the top there, plus these two circles, plus the two circles, will give you the area of the rectangle, because now you covered up everything. You covered the shaded part here, you covered the missing parts there, and the circles will give you the area of the rectangle. Now that is quite nice because now you have an equation, you see, right? And I know how to find the area of the circles, and I know how to find the area of a rectangle. I've got formula for those. I didn't have a formula for the area of the shaded part, but I've got formula for these things. So S plus S is 2S. The area of a circle is pi r squared. So what is the area of the circle? The area of the circle is pi times its radius squared. Now, how do I find the radius? Well, now that you have to think a little bit. But you can see this entire length here is O. Or the diameter from here to here, right, is the diameter of the circle, which is 8. So therefore, the radius is 2. This is the diameter. It's equal to 8. So the radius is equal to 2. See? 4, I'm sorry. So this is pi times 4 squared. 4 times 4 is 16 pi. So that's the area of one circle, that's pi r squared. So the area of two circles is 2 times 16 pi. Right, so this has been taken care of. And that's equal to the area of the rectangle. Oh, but the area of the rectangle you knew in grade 4 or 5 or whatever, I don't know. So it's length times breadth, 16 times 8. And 16 times 8 is 128. Okay, so now your unknown is 2s. So when you take 2s is equal to, divide right throughout by 2, and take the 32 on the other side. 2s is equal to 128 minus 32 pi, because you take it to the other side of the equation. That's 2s, so s is 64 minus 16 pi. And we were told the area of the shaded region, this is s. This is what we said was s. And we are told that s is equal to x minus y times pi. We were told that. So now immediately you have what x is. X is 64 minus 16 pi. So y must be 16. See, x is 64. There's your x here. You're supposed to calculate x plus y. Y is 16. Always answer the question. What is the value of x plus y? So the answer is x plus y is 64 plus 16, and 64 plus 16 is 80. So that's the answer. So the answer to this problem, the area of the shaded region, or not the, well, the area of the shaded region was some funny thing, but the x plus y is 80. Okay, now that's a rather tricky one. Let me see how many of you got that out. 4 people have left. Okay, a number of you have actually solved this problem as well. So that's very, very nice, because it's not a very easy problem. So we got people here who are in line for round 3. In round 3, you've got a large number of people who are taking part in round 3. Everybody who has passed round 2 will go into round 3. And usually from, there are almost, I mean, at one time I know there were almost 5,000 students, but they will only take 100 students into round 3. So you got a very small chance, but don't bother about whether you get into round 3 or not. That's not important. What is important is that you are joining this class to learn how to solve problems, interesting problems. Whether you go into taking part in some competition or not is not so important. What is important is that you are learning how to solve complicated problems. And you can see it's not that complicated. If you use your common sense, you can answer a lot of questions. All right, I'm running low on time, so I'm going to go on to the next one. I might go on past 6 o'clock, so just bear with me. Or I'll go a little bit faster. I do know that I'm going to give you all the solutions. You see, the solutions are here. Let me just clear this thing out and I'll show you. I'm going to send this entire file to you. So in this class, I'm simply explaining the solutions. So can you see? There's the solutions here. So I'm explaining all these things to get x plus y equals 80. Okay, so the solutions, I'm going to send this to you. All of you will have access to this. And also the recorded version will also be posted on Google Classroom. So you have this together with the recorded version. So you'll have enough material to work on. So I'm going to take advantage of that fact and go a little bit faster. The next problem. Yeah, unfortunately, these are the more difficult ones. I should spend more time on this. So you've got determine the units digit of these. All right, so what's happening is that you've got a thing called a factorial. Yeah? This exclamation mark is called a factorial. If you go in Google, or not Google, Control Find, in my book, you've got a whole story about factorials. So you can read that. This thing here is read as factorial, F-A-C-T-O-R-I-A-L. So you read this as 3, like that. You read it as 3 factorial, like that. See? So we've got 1 factorial plus 2 factorial plus 3 factorial and so on. Well, what do you mean by this? This 3 factorial actually means you multiply all the numbers from 1 to that number. So it's 1 times 2 times 3. That's 3 factorial. If you want to work out what 7 factorial is, that's 1 times 2 times 3 times 4 times 5 times 6 times 7. Right. So it can be quite a big number. Okay. So that is what you mean by factorial. So the problem here is to calculate this. You've got a sum here which has got a lot of numbers in it. You've got actually got 2019 numbers here. and you are asked not to add them up, but just to calculate the units digit, right? Okay, so you're adding a lot of numbers and you're calculating the units digit. If I had a number of numbers, right, the units digit, I'll add these numbers. 8 plus 5 is 13, plus 6 is 19. And this will be the unit digit. I need to add only the units of each of the numbers to get the sum, the units digits of the sum. I don't have to worry about what this is. The question is just to find the units digits of the sum. So I don't have to have all these numbers. I need to have only the last digit of each of these numbers and add them up to find out what the units digit of the sum is. Okay, so just bear that in mind. So to add this thing up here now, I'm going to erase, maybe I better not erase it. Okay, 1 factorial is 1. I'm going to add these numbers up. Let's put it up here. 1 factorial is 1. 2 factorial is 1 times 2. 3 factorial is 1 times 2 times 3. 4 factorial is 1 times 2 times 3 times 4. Now you come to 24. Now observe, to get to 3 factorial, I simply have to multiply this by 3. To get to 4 factorial, I have to multiply this by 4. Right? If you want to come to 5 factorial, it's 1 times 2 times 3 times 4 times 5. But we already, if you know what that is, you have to simply multiply that number by 5. I already know what this is. So I'm going to multiply this by 5. And I'm going to write down only the units digit. 5 times 4 is 20. So I've got some number. Actually, we know what the number is. 5 times is 120. The next one, right? You're going to get, the next one is 6 times this. The units digit is still going to be 0. The next one is 7 times this. Units are going to be 0. So the units digits remain stubbornly at 0 all the way beyond. Even up to 2019, we don't care where it ends in, but the units digit is always 0. So if I'm adding all these numbers, all I have to do is to add the unit digits here. 1 plus 2 is 3, 3 plus 6 is 9, 9 plus 4 is 13. And I'm not bothered about the rest of the stuff. I've got the units digit, which is 3. Because I don't have to add the zeros. You come to 13 and then you're going to add 0 all the way. So the answer, the units digit will be, it's 13, but you'll put 3 here and you'll carry 1, but I'm not interested in the other stuff. I'm only interested in the units digit. So the answer to this problem is 3. Okay, so let's just go on to the next question. So this is problem number 20. Let's go to problem number 21 now. The 21 is a kind of a tricky problem. Problem 21 says, so athletes A and B, they run at constant speeds in opposite directions around an athletics track. All right, so I've got an athletics track. I'm going to assume it's a circular track. Okay, let me draw the diagram because evidently you need a diagram because they're running around a track. So see what goes on here. They begin at the same time from the same point. So they start somewhere here, maybe here. So this is the start. But they run in opposite directions. So one guy runs that way. Okay, maybe A. Suppose A is running this way. And B runs in the opposite direction. Okay, obviously they're going to, it's a circular track, so they are going to meet somewhere. But they just carry on running because they say they carry on running, right, at the same speed, constant speeds. So they don't stop and say hi or anything like that. They just carry on running at their own speed. So A goes round and round and round and round, and B goes the other direction, round and round and round. So you would expect them to meet several times. Okay. It's given here that for every 2 laps that B completes, A completes 3 laps. The question is, how many times do they pass each other during A's first 10 laps? Right, this is quite a tricky question because what happens here is A goes 1 lap, 2 lap, 3 laps, and so on. And he does 10 of those. And having done 10 of those, he comes back to the starting point. How many times has he crossed B? How many times has he passed B? The only information that is given is that for every 2 laps that B completes, A completes 3 laps. So there's a ratio problem here. A is to B is 3:2. What are we saying here? That A completes 3 laps and B completes 2 laps. Right? So if you are, now this is a proportional problem, right? So in 1 lap, right? If you divide 1 lap into this ratio here, 3:2, the total number is 5. So in 1 lap, A would be doing 3/5. He would have covered 3/5, and B would have covered 2/5. See? So now we're dividing 1 lap. I want to see where they meet, right? I want to see where they meet the first time. So A would have covered, but you could have figured it out because A is traveling, obviously is traveling faster because he completes 3 laps while the other guy only does 2. So A would be going faster and he would meet this fellow somewhere here maybe, quite down the line. B would have just done 2/5 of a lap only, and A would have done 3/5 of a lap because this distance to this distance is 3:2. Okay, but the important thing here is that they both meet here. At this place, A and B are together. Right. Now to summarize, I'm going to get on to my whiteboard. I'm going to say the following, and hopefully you have understood what I said here, because I'm going to start sharing now a whiteboard. Okay, what we've seen here is that A and B meet when A covers 3/5 of a lap. A and B meet when A covers 3/5 of a lap. So each time A does 3/5 of a lap, he meets B. Okay, which means that if I go back to my diagram, okay, so what it means is that if both of them meet somewhere here, A and B are together here. 3/5 of a lap. Now, the next time they meet, now this is a new starting point. This is just like they're starting all over again. And he's carrying on in the same direction, and this guy goes in the same direction. So A will have to go to another 3/5 of a lap to meet B again. You see? So each time A covers 3/5 of a lap, he will meet B. So A meets B whenever he covers, I'm using the word covers or runs, 3/5 of a lap. Each time he does 3/5 of a lap, he meets B. So if you want to count, now he finishes 10 laps altogether. Right? Like for instance, let's put it this way. Suppose he does 9/5 laps. Every time he does 3/5 of a lap, he meets him once. If he does 9/5 laps, then he would have met him 3 times, because 3 times this will be 9/5 of a lap, right? So what we are saying is that the number of times he meets him, if you multiply that by that number, you will get the total distance he travels. So the number of meetings will be 10 divided by 3/5. Now this is the tricky part. See, if you didn't have a fraction, suppose you say A meets him whenever he covers 2 laps, 2 full laps. So if he covers 2 full laps, he meets him. 4 full laps, he meets him twice. 6 full laps, he meets him 3 times. 10 full laps, you will meet him 5 times. How do you get 5 from, if he meets him every 2 full laps, how do you get 5? You divide 10 by 2, and then you will know how many times he meets him. It's exactly the same thing. Now you have to divide 10 by a fraction, because he only does fraction of a lap, not 2 laps. So when you do this, you see that you can actually get 16 and 2/5. The 16 and 2/3, right? When you're dividing fractions, you must invert and so on. I'm not going to do that. But this is, you get 16 and 2/3. So he would have covered, how many laps he would have, full laps would he have covered altogether? But the 2/3 means that when he covers 10 laps, when A covers 10 laps, B is not beating him at this place. B is still running somewhere else, right? But he would have already covered, would have met him 16 times already, and still has to meet him for the 17th one. So the question is, how many times does he pass each other in A's 10 laps? The answer is 16. Okay, so problem number 21 is quite a demanding problem, but the answer is 16. Okay, you can think about it, and you can listen again to this recording, and you will see, try to get a better understanding of this. Okay, so the answer to problem 21 is 16. Let's go on to okay, I want to go back to my new share. Go back to my question. Okay, now that's 21, and now we're going to problem question 22. Okay, I don't have much time. It takes me a long time to move. 22. Okay, I'm going to do 22. We have very little time, so I'm going to go on past the time. Those who have to leave at 6, you are free to leave, and I will continue to finish this thing off. Unfortunately, I have to finish this thing because yesterday I finished the whole 25, and I want to be on par. Today I took a longer time to explain. So let's look at number 22. A number is chosen at random. Okay, so I'm going to assume you know what the question is. So you choose a set which has got 3-digit numbers. And these 3-digit numbers read the same backwards and forwards. And you also got 4-digit numbers which read the same backwards and forwards. So you can start with take your mic off. A 3-digit number, you can start with this. It reads the same backwards and forwards. And the next 3-digit number will be 111. The next one is 121, and so on. If you write down all the 3-digit numbers, and also write down all the 4-digit numbers, which read, you see, they say 3 and 4-digit numbers, which read the same backwards and forwards. The first 4-digit number, so you got a lot of numbers here, but the first 4-digit number will be 1001. But then the next one, which reads the same backwards and forwards, right? You'll have to have these two to be the same if you read it backwards and forwards, right? So if you add the 2 as 0, the next one will be 11. The next one will be 122, and so on, right? Going all the way up to, oh, by the way, this thing will finish, the 3-digit numbers will finish at 999, right? And this will finish at 9999. See? So these middle ones will be the same, and the first and the last will be the same. Now, the question is now, how many elements are there in the set? That's a challenge. So you have to count. You know how the numbers are created, so you have to count them. All right, now I would do it like this. I'm going to go on to my white page again because I don't have enough space. I hope you understand what we have been doing here so far. So I'm going to clear the screen. Okay, if you go from 101 to 191, that's enough though. Then if you go from 202 to 292, if the first and the last digits are 2, you're another 10 there, because the middle digits can be only from 0 to 9. And like that, you go on to 909 to 999. If the first and the last digits are 9, then again you got another 10 digits there. That's how we finished off with the 999. And that finishes off all the 3-digit numbers. Now, how many have you got altogether? Well, you got 10 in the first lot, 10 in the second lot, and you got 9 lots altogether, counting from 1, 2 up to 9. So you got 9 tens, which is 90. You got 90 altogether. Right, now you go on to the 4-digit numbers. In that lot, oh no, I'm sorry. You go to 1991. The first digits and the last digits are 1. Right, so the middle digits could be 0 up to 9 again. So again, you have another 10 here. And then starting with 2, you can go 2002, going up to 2992, right? Got another 10. Exactly the same thing is repeated here, and you got another 90. So your original set S means has got 93-digit numbers and 94-digit numbers. So S has 180 numbers altogether, elements. So you can actually count the number of elements, right? And the question, okay, let's just go back to the page because we know now S has got 180 elements. Right. So to get back to our question, the question is, what is the probability expressed as a percentage that the chosen number is a 4-digit number? Okay, now the probability, what do you mean by probability? It means the number of 4-digit numbers so the probability is that the chosen number is a 4-digit number. So this will be the number of 4-digit numbers over the total number. Sorry, this writing is so bad. Let me do it better. Over the total number, and the total number, total, the total number in the set altogether. Now we already know that altogether the set that we're talking about has got 180 such numbers. And how many of those were 4-digit numbers? We saw that it's 90. We had 90 4-digit numbers and 93 digit numbers. So the answer is 90 over 180, which is a half. But the probability, see again, say expressed as a percentage. You must read the question. And if you write on a half, you lose all the marks, although you went so far, because you have not written it as a percentage. So it's 50%. The answer is 50. In this round 2, I suspect, I think I'm right, that the answers are all whole numbers. See, that is why they don't give you half, because that can't be an answer. The answers are always whole numbers. So if they write it as percentage, 50 is a nice good whole number. So, yeah, so just remember that. If you get an answer as a fraction, you must know your answer is wrong. It has to be a whole number. Okay, now let's just go on to the next problem. So we're going on to problem number 23 now. And problem number 23 is quite a tricky problem. It says that A and B are both 2-digit numbers. They have a highest common factor of 6 and the lowest common multiple of 180. LCM is 180, the HCF is 6. So now, let's record that information. HCF of A and B. These are A and B represent 2-digit numbers. We don't know what the numbers are. Is 6. LCM of the same 2 numbers is 180. Okay, now there's a very important fact about HCF and LCM, which I'm going to share with you. You go and look at the book. All of you are getting the book free of charge, so make use of it. And look for LCMs and so on and so forth, lowest common multiple. And there's a nice little result there which says that the HCF of 2 numbers multiplied, I'm going to put that in brackets, multiplied by the LCM of the same 2 numbers, interestingly, is equal to the product of the 2 numbers. And that's a very interesting fact, that HCF times LCM is equal to the product of the original 2 numbers. See, if I take, for instance, suppose let's take a simple example. Take 12 and 16. A equals 12 and B equals 16. Right? you can see quickly that HCF is 4. That's the highest common factor. The number that goes into both of them is 4. And LCM would be 48. See, 12 goes into 48 4 times, 16 goes into 48 3 times. So 48 is a common multiple of the two, and nothing smaller than that will work. Right. Now, we just said that the HCF times LCM, that is, so here you got 4 times 48, is equal to the product of the two numbers. Now, if you take 12 times 16, those are the two numbers. I'm sorry, 4 times 48. Now, if you work this out, you get 192. And if you work this out, you also get 192. So they both are equal. Now, that's just verifying it for this particular example, but it's always true. Very interesting fact. Okay? And I'm going to use that fact just now. So that's a useful thing to know in round 2. Right? In fact, there are lots of useful things that you need to know, which are not told by your school, by your teacher, and primary school teacher. But in these classes here, you will learn a few things. Okay, now let's just get back to this. If the HCF of A and B is 6, it's the highest common factor of A and B. So 6 is a factor of A. I'm going to say it again. 6 is a factor of A because it's not just a factor, but it's the highest common factor. But it's a factor. If it's a factor, that means A is 6 times something. Let's give a name to this. Likewise, the LCM, for B, the same situation. You got 6 is a factor of B, so B is also 6 times something else. We'll call it N. Right? Because 6 is a factor of both of them. Now observe that M and N, they can't have any common factors. But think about that. See? For instance, if 2 suppose 2 goes into M and 2 also goes into N, then you can take the 2 out and make that 12 and make this 12 also. And then you will have, 6 can't be the highest. You see, you got 12 is also a common factor. So that's impossible. So M and N have got no common factors. Okay, just bear that in mind. And now I'm going to see, I'm going to take the HCF times the LCM, right? I'm going to use the little fact that we had here. Multiply these two. We know 6 times 6 is the HCF multiplied by the LCM is equal to, we said, is a product of the two numbers. So the two numbers are 6M and 6N. Okay, 6M and 6N. So you got 36 MN equals 6 times 180. So 36 goes into 185 times. So MN is equal to 5 times 6, which is 30. All right, MN, M times N. All right, okay, now that will now, you see, remember the problem was to find A plus B. Okay, I'm not going to go into the whiteboard because I need this information from this page here. So I'm going to just take out these things. I don't need these things anymore. I need some space. So M times N is 30 and Mn have got no common factors, but the problem was to find A plus B. And let's just look at the question here. A plus B we need to find. That is 6m plus 6n. So that is 6 into m plus n. So to find A plus B, I need to know what m plus n is. So that becomes the question mark. What is m plus n? You see, this is round 2 now. So there's a lot of thinking involved here, and understanding about what you mean by LCM, what you mean by HCF, and so on. So you've got, to summarize, I've got the product of the two numbers is 30. And I know they have no common factors. And there are quite a few possibilities. If I put them like this, m comma n, like that, to see what are the possible values for m and n, I can make m equal to 1. The product is 30. And then you could make m equal to 2. Then you get 15. Which two numbers multiply to give you 30? You can have 3, 10. 4 doesn't go into it, but 5 does. 5, 6. 6 goes into it, 6, 5. But now you see these numbers are being written backwards. So these are your m and n. I need to calculate m plus n. See? So m, there are many possibilities for m n. So m plus n, let's see what are the possibilities for m plus n. Let me just write this neatly. So there are many possibilities for pairs, m and n. So m plus n could be 1 plus 30, for instance. If I had this, I would have had 17. If I had this, I would have had 13. If I had this, I would have had 11. If I had this, I would still have 11. Now you'll see you'll go backwards now because you're getting the same factors. See? So the only possible values for m plus n are these, but the question is, what is the smallest possible value for a plus b, right? So you're looking for the smallest possible value for a plus b. So therefore, you're looking for the smallest possible value for m plus n. And the smallest possible value for m plus n is 11. There it is, sitting quietly there. That's your smallest possible value. And that's the question that is asked. What is the smallest? So there are many possible values for a and b, which we've written it down, So this will be 6 times 11, because that's the smallest value for m plus n. And the answer is 66. So that is the solution to problem number 23. Of round 2. Okay, I'm going to skip problem number 24 as I did with my other students. But that's not so difficult, so I don't have any time for it. So what I'm going to do now is I'm going to go to problem 23. I'll go to problem 25 because I'm sure many of you tackled the problem 25. 24, there's some equations here which you have to solve, and I can leave that to you. You can see the solution, and I'm sure you'll be able to understand it. But the last problem is this: how you got this funny figure here, and all these are squares, and you got some lines drawn, and the question is to find the value of x. Now problem number 25 is the last problem on this in this paper. So you might think, oh no, this is going to be quite easy because to find an angle, I can always find an angle. It's not difficult to find angles. But when you try to do that, you will see that you really land up with unknowns. You have too many angles and you wouldn't know what to do. It's not easy to solve this problem without doing constructions. So I need to draw some other extra lines to solve this problem. Many problems in geometry involve constructions. I mean, in theorems, you always have a construction because those are difficult problems. How do you prove that these angles of a triangle add up to 180 degrees? If you just look at the triangle, you can't see the 180 degrees. But when you look at the proof of the theorem, there is a construction. So some of the more difficult geometry problems have got constructions in them, like this one. So we have to identify the construction. Now, to identify a construction, you have to think very carefully, and you say, well, I've got this x here is sitting at a very awkward place here, right? Can I transfer it to some other place, right? So if you look at it, you'll see that x is between these two lines, right? Now, you can transfer this thing to another place. Now watch, by joining this line here. By joining that. Let me use red to show these construction lines. So we can see that these lines were not there in the first place. So this is a red line. Now, it looks as if this x here, it looks as if these two lines are parallel. And I'm sure many of you will say, yeah, okay, you can see clearly they are parallel. All right, let's come back to that later on. And then if they are parallel, it means that this angle here must be equal to this angle here. You can see parallel, parallel, and these are corresponding angles. So this angle here will be x. They will become corresponding angles. Okay, so you can say that angle is equal to x. Now let me explain why these lines are parallel. It's not easy to see why they are parallel, but in geometry you can't say, well, they look as if they are parallel, therefore they are parallel, right? In this problem, you can get away with it because you're not allowed, you're not asked to explain anything. But if you happen to get a round 3, you can't say they are parallel and just stop there. You'll only get a small, maybe 1 out of 7 marks. You have to explain why you think, why you say they are parallel. Everything has to be explained. And I can explain it to you very quickly because, you see, this side is equal to this side. I'm going to look at this figure here. You can see this side is equal to this side. That's quite clear. On the sides of the same square. And this line is also parallel to this. That's also clear. That we know. So therefore, this figure here has got the property that one pair of opposite sides are equal and parallel. One pair of opposite sides are equal and parallel. Now, very important property of parallelograms. I know many of you have not done parallelograms, but if you got one pair of opposite sides equal and parallel, then it becomes a parallelogram. In other words, the opposite sides are parallel, and that's the reason for that. Okay, so you're not expected to do that because that's more like a grade 10 problem or grade 11, grade 10 more likely, and you guys are in grade 8 and 9. But if you guess it, that's fine. Right. Now, another thing that I'm going to join is I need to join something else, and that is, see, this is a hard problem. Very few people will get this thing out unless they guess the answer. Another thing you're going to join is these two lines. Okay? Those two lines. Okay, now it turns out that this line and this line are actually equal. This line and this line are actually equal. And more than that, the angle between them is the right angle. The angle between them is the right angle. Now, we can prove that. We can prove that using congruency. And how do you prove it? You actually, to prove it, again, you have to perform more constructions here. So this is a not an easy problem at all. In fact, I would say that 99% of our teachers would not be able to get this answer. And if they do, they'll find it difficult to explain why. Okay, so what happens here is that let's explain why these two are equal. They are equal because if you now look at my picture, and if I compare these triangles here, that one and that one, you will see those two triangles are congruent. You see? Because you got two lengths here, those are equal, these are equal, and we already know that this angle is 90 degrees. See? So therefore, this is the right angle, hypotenuse, and a side. Those two triangles are congruent for that reason. And because they are congruent, these hypotenuses will be equal. That is what I said earlier on. These two are equal. But I also said that these angles here, this angle here is a right angle. Okay. Now, if you call this angle, suppose I call this angle here, or that's X. Suppose I call this angle Y, that small angle, corner angle, and call this Z. Right? Y is here, Z is here. Now, if these triangles are congruent, so this is Y here, and that must be Z, then you can see quite clearly that Y plus Z is 90 degrees. Because in a right angle triangle, these two will add up to 90 degrees. But on this line here, Y plus Z is 90, which means that the remaining angle must have been 90. See? So now in this diagram here, you got this angle is 90, this is equal to this. So therefore, X must be 45 degrees. You got a right angle triangle, which is isosceles, so X is 45, and that allows you to say that this is 45. Right.